Okay, let's look at few questions on the overfitting and underfitting. So, suppose you train a classifier and test it on a held out validation set. It is nothing but the test set, test where you are going to test your model, right? And 80%, and it is given that the 80% classification accuracy on the trainee set. So your model have 80% accuracy on the trainee set and 20% the classification accuracy on the validation set, or you can say on test set where you are testing your model. So on the test set or on the validation set, your model have 20% accuracy, and on the trainee set your model have the 80% accuracy, or on the validation set your model have 20% accuracy, right? So what kind of problem your model is suffering? So from what problem is your model most likely suffering? So you see that your model have 80% accuracy on your trainee examples, right? So if you have idea, then maybe we can just look at the. So as you increase your model complexity, right? So model complexity is increasing in this direction. So your then your model is going to perform very well on your trainee examples, right? As you increase your model complexity, right? So let's say that what I am drawing is the performance uh, uh, as you are increasing your model complexity. How? So as you will increase the model complexity, your model is going to have the good performance over your training example, right? So as you will increase, that model complexity will have the good performance. So you can say that this is a performance of your model on the training example. So let me call it TE or training examples or the trainee set, right? But with the increasing model complexity, your performance on the validation set or the test set is as you increase the model complexity, then that is going to decrease, right? The performance is going to decrease as you increase the model complexity. On the test set, your performance of your model is not going to uh, will not do the good job on the test set, right? So this is for your you can say the test set, right? And if you know that this region, what we call, where we have the uh, uh, you see the performance difference between your uh, uh, performance difference of your model when your model have more complex, then the it will have the good performance on your training set, but it will not have the that much of good performance on your test set. So this reason what we say is the overfitting, right? So you can say this reason is overfitting. That means your model is fitting into your trainee example on which you have trained, right? But your model is not capable of doing good on the test set that your model haven't seen yet, right? Or you can say that the robustness of your model is not good, right? If it would have the robust model, then it would have given you some kind of good accuracy or the performance over the test set, right? And this reason what we call is the where your model complexity is not too much, and at this you will have not that much of the performance with the trainee set or the test set. So this is the reason where you can uh, call this is the underfitting, right? Okay, now let's answer this question. So the first question is that your model have 80% accuracy on the trainee set and the 20% accuracy on your validation set. So this question is talking about this reason, right? So this is the performance. So your model from most likely suffering overfitting, right? Now let's look at question B. So in question B, it is asking that if it is overfitting, then how you can improve, right? Uh, improve your classifier's performance on the validation set. So how you are going to improve the performance of your model if it is overfitting, right, on the validation set? So what we do, we may decrease our model complexity. And how you will be decreasing your model complexity? By removing some features from it. So the answer for this would be by removing some features. Okay, now let's come this C. Briefly justify, collect more training data, throw out some training data, right? If your model is overfitting, then would you collect more data, or would you throw some throw the training data, right? So let me explain this one. So what would you do? So what is happening that your model is uh, overfitting your training examples, right? So what we can conclude that your model have more capacity to cover more data, right? If it is overfitting, then if it is overfitting, that means it is fitting into each and every example of your training data. What does it mean? That your model have more capacity to explore more data, right? So your model is demanding more data in case of the overfitting, right? Because your model have the capacity to explore more data, right? And it have the capacity to cover more data. Uh, so so if it is if your model is overfitting, that means your model is fitting into each and every data. You can say that your model is fitting each and every data, and it has the capacity to explore more data. So it is demanding more data, so you can say you can collect more data, right? So the correct answer for this is uh, if it is overfitting, then your model needs the more training data, right? Now this question, that assuming features are outcome count and k is the Laplace smoothing parameter controlling the number of extra time you pretend to have seen an outcome in the trainee data. So increase k or decrease k. So if you recall this Laplace smoothing, right? So where we in which so we have this Laplace smoothing in the naive base, right? And and in, if you recall that uh, what in what case we do the Laplace smoothing, right? Let me just remind you that when your model have not, or let's say you have the dictionary, right? So I'm taking the example of where you are classifying, your model is classifying the ham or spam emails, right? Suppose your model haven't seen a word that is not present in your dictionary. So you trained your model with the given dictionary, or and that how you have formed the dictionary by collecting all old emails, right? So but there is a word that your model haven't seen in during the trainee time, or that is in not in your dictionary, but at the prediction time that word came into picture, and your model now had the job to predict if it is a ham or spam, but your model haven't seen that particular word. Then your model will have then what your model is going to classify, and that since it haven't seen your that particular word is not seen by your model, then the belief about that particular word your model is going to make is the strong one, right? What does it mean? If your model haven't seen a particular word, it doesn't mean that it so if you are not doing any kind of Laplace smoothing, then your model is overfitting, right? And it has like the you can say very strong pre-assumption about the word that your model haven't seen, right? Because the probability you will return is zero, right? And zero probability is a very certain, right? So your model cannot be too much certain about something that your model haven't seen, right? So there you see that Laplace smoothing will came into picture, and it will say that you add that particular sample into your data set, right, in all cases. So uh, to avoid this problem, what we do is we increase the value of this k, right? Okay, and if you have the overfitting, then if you are using that the bias net, and what you will do, you will add the edges or remove the edges. So you suppose you have the bias net maybe something like this, right? So it is asking that you will remove the edges or add the edges. So uh, in this case, if we have the overfitting problem, then we are going to remove the edges, right? Because less the edges, less you will have the conditional probability table, right? So in this case we are going to remove the edges, right? Okay, I think we have answered all this question. Okay, now let's move. Okay, so now we have few more question on the same. Suppose you train a classifier and test it on a held out validation set. So held out validation set means a particular set of data that your model haven't seen, and you with that particular data you are testing your model, and on this it gets 30% classification accuracy on the trainee set. Okay, okay, so this 30% is accuracy on the trainee set of your model, and 30% classification accuracy on the validation set. Okay, so you see 30% accuracy on the, so we will be somewhere here, right? 30%, so we will be in the underfitting region, right? Because your model is not performing even good on the trainee set or even on the validation set. right? So we are in the underfitting region. So for what problem your model most likely suffering? So for underfitting, right? And which could reasonably be expected to improve your classifier performance on the validation set. So if you want to increase the performance of your model, if it is in fitting, then what you would do is that you will add extra feature or remove some extra feature. So obviously in this case you will be adding some extra feature to increase the complexity of your model little bit, right? So that will, maybe if you are with the 30% you are here, and if you further increase your model complexity little bit, then you will have the, you see that you will have the good performance. You will increase your performance somehow on this the test set or the validation set, right? And now this is little bit like, if your model is underfitting, you will collect more trainee data or throw out some trainee data. What would you do? So the point is that uh, if we have more data, there is no like you can say, so if we have the underfitting, the point is that uh, there is no harm in keeping the more trainee data, right? So in this case also we will be keeping the more training data, but it will not, I can say, exactly address your underfitting problem, but there is no harm in collecting more data, so you can go with this. Okay, so okay, that is what about some few basics question on the overfitting and the underfitting. Thank you.